I don't know how many of you have seen a topographic map before, but this is a section of a topographic map. Of course, is entirely the fruit of my imagination, and what you can see, you can see level curves or a contour map. Each curve represent different elevation, and you can see that the units are in meters. So I went metric on you here. Okay, and also the scale of this map is 1 to 10,000. Again, some of you may know what I'm talking about, some of you may not. If you spend some time in military, I think Adam knows exactly what I'm talking about. So probably Michael, although he was in a submarine, so I don't know if they have a chance to look at the topographic map. But you had a chance to look at sonic contours, did you? Underwater. Anyway, so what does it mean, the scale? It means that if I'm going metric, then each millimeters on a paper is 10,000 millimeters in real life. Each inch on the map, on the paper, is 10,000 inches in real life. So since we're going metric, and I'm going to measure probably distance in millimeters, let's say 1 millimeter on the paper equals to how many meters in real life? 1 millimeter on paper equals to how many meters in real life? And Adam got the right answer. It's 10 meters, because how many millimeters in 1 meter? 1,000. 100 centimeter, but 1,000. So 1 millimeter is 10,000 millimeter in real life, or 10 meters. Okay? And we're actually going to measure. The question is, in this case, what is the slope of the hill, or the rate of change? And obviously, this is a hill where the top is at the 120 meter level. And the question is, what is the slope of the hill, or the ascent, or descent if you're on top of the hill in a certain direction? And let's go with the southeast direction. I made it probably the most moderate slope. So here's the question. What is the slope of the hill let's say if you climb from the southwest direction. There is on top. Yeah. So this is the north, and this is the east to the right, and west to the left, and south to the bottom. So if we put the top right here, okay, I'm at the 45 right there. So I'll mark a point right here. Okay. All right, so we are coming, this is the southwest direction. We're climbing from here. So the solution, we know that the elevation, if we start right here, well, this is the contour, or the level curve is 100 meter. We go, and let's assume that the top is all flat, it's 120. We don't have any other way to go. Nobody told us that there is elevation higher than 120. So we can go from here to be on the safe side. Okay, so the rise, okay, rise equals 20 meters. Okay, so what is the run? The run is simply we need to measure the distance from the beginning to the end in millimeter, and you can see it's about 45 millimeters. It's not about, it's exactly 45 millimeters. Okay, so the run, sort of, so rise and run, equals 45 millimeters. 45 millimeters translated to 45,000 millimeters, which is equals to 45 meters. Okay, so the slope equal rise over run, as you know, equals 20 over 45. Okay, this is reduced to what, 4 over 9. Actually, this is 450 meters. It's each millimeter is 10 meters. So it translates 450 meters. So it's 4 divided by 90. And I think if you put it in the calculator, it will be 0.044 repeated, right? Try that if you have a calculator. But I think 1 over 9 is 0.1. 1 over 90 will be 0.01. 20 over 450.
45.
Right. It's 2 over 45, but I like the divide by 90 because I know exactly what it is. When you divide by 9, it's 0.11 repeated. All right? And plus, you know, initially I thought it was 20 over 45. You're right. Anyway, this is what we care. And what is this? This is really, in percent, it will be 4.4%. This is the slope of the hill. Willie, I'm sure you asked me a question, but I couldn't hear your question. Right, I measured 45 millimeters.
It says 450,000. You need to, up at the top right, you wrote 45,000.
450,000, yes. Yeah, because each millimeter on the paper is 10,000 millimeters in real life. So it's 450,000 millimeter or 450 meter. So that's the horizontal distance. So what's the purpose of this exercise is to show you that unlike a single variable calculus, the slope is a slope is a slope. When you take the derivative, you get the slope of a tangent. But when you do multiple variable derivative or partial derivatives, it depends in what direction you go. Okay. For instance, if we wanted to find the slope in the easterly, coming from the east, it will be much steeper because the distance will be what? Will be about 16 to 18 millimeters. We actually can measure it, so it will be 14 millimeters. So 14 millimeters is 140 meters compared to 450 meters. So now you have elevation of 20 meters over a distance of 140 meters. That's much steeper. Okay, so this is let's actually do it. So let's put A here and B. What is the slope of the hill? If you climb from the east. Well, the solution here, we'll do it again. We'll take that line. This will be the east. So this is the east direction. So the distance from here to here is 14 millimeter, right? So would he say that the run in this case equals 14 millimeters, and 14 translated to 140 millimeter in real life, or 140 meters. Actually, let's change the equal, because like so, put the implies error. So 14 millimeter implies 140 millimeter. In reality, it's 140. So the slope now equals 20 divided by 140, or this will be 2 over 14, or 1/7. 1/7 is approximately, I think, 0.14, but again, or 0.1314, so approximated, so, or 14%. So which way are you going to climb? You're going to climb from the southwest or from the east? You're going to climb from the southwest, because it will be easier to climb. No, let me put it to you in a different way. You are an engineer. You need to design a road from the bottom of the hill to the top of the hill, right? You're not going to go from the east, because it's unreasonable. I don't know if you ever drove on a 14%, but those of you who've been to San Francisco, there is probably one of the steepest streets in the United States, or maybe even the world. It's called Lombard Street, if you heard about that. The steepness over there, if memory serves me right, I drove up there in 1975, so that was a year ago or so. So, and if memory serves me right, that's 15%. It's unreal. It's really, you drive, you sit in the car, and all you see ahead is the sky. You really don't see the road. That's 15%. That's unreasonable. On the other hand, 4% is very steep for vehicle, but it's doable. So as an engineer, you go and do a serpentine to even reduce the steepness. But there is also cost issue, because you don't want to make the road too long. So anyway, this is just a practical example of what is the meaning of directional derivative. So, you kids are okay over there? You're touching each other? You need a quiet place? Hey, no problem. You can turn the camera.